What if communication barriers could disappear instantly? For millions of people with hearing and speech impairments, everyday communication remains a challenge.
Sign language remains something most people don't understand, which creates real communication barriers between sign language users and non-signers in everyday interactions. On top of that, many existing recognition systems require wearable sensors, expensive equipment, or cloud-based processing, making them costly and impractical for everyday, real-world use.
This project introduced a real-time AI-based sign language recognition system designed to bridge that gap. The system runs on Raspberry Pi, enabling a compact standalone embedded solution. The system uses a camera to capture hand movements and applies computer vision techniques to detect 21 hand landmarks in real time. These landmarks represent the position and structure of the hands, allowing the system to interpret different gestures accurately. The extracted data is then processed using machine learning models to classify both predefined gestures and alphabet-based inputs. This enables the system to support dual mode recognition, giving users flexibility in how they communicate. The system responds instantly, providing smooth and responsive real-time feedback. It maintains consistent recognition even with variation in movement. Recognized inputs are combined to form meaningful words and sentences. The system translates recognized text into another language in real time. It can also convert text into speech for easier communication.
Our solution is a standalone Raspberry Pi-based system that recognizes selected sign language gestures in real time. It uses MediaPipe hands to detect and track hand landmarks, then classifies the gesture using a feed-forward neural network. The system integrates a graphical display, live translation, and text-to-speech output, converting recognized signs into voice instantly, with everything processed locally.
This solution is affordable and easy to use, making it suitable for real-world use in school and public environment. It provides a practical and accessible communication tool. Unlike wearable sensor systems, this approach uses a standard camera. This makes it more comfortable, easier to use, and more cost-effective. This system reduces communication barriers and supports more inclusive interaction. It provides a practical solution for improving accessibility.
We also made sure to keep this system affordable. It's built using hardware that's easy to get and reuse, along with completely open-source software like Python, OpenCV, MediaPipe, and PyTorch. Since everything runs locally instead of relying on cloud processing or wearable sensor gloves, we managed to keep the total cost down to just Rm1075. One of the key parts of this build is the Raspberry Pi 5, which we got from Citron Technologies. Citron's been a great source for reliable components, and having that support made it a lot easier to get everything running smoothly for real-time processing.
This system has strong real-world potential as an assistive communication device for schools, hospitals, and public service counters, places where communication gaps between sign language users and staff often occur. It's also built to grow, with room to expand into dynamic signs, full sentence translation, and multiple languages. Beyond assistive use, it also works well as an embedded AI educational kit for teaching computer vision and machine learning.